Hello everyone, my name is Wanxing Chang from Shanghai Tech University. It's my great pleasure here to present our work Unified Optimal Transport Framework for Universal Domain Adaptation. This work is co-supervised by Ye Shi, Tuan Hong, and Jingyang Wang. So, conventional domain adaptation setting restrict the source and the target label set are the same. But when it comes to a more realistic setting called universal domain adaptation, two domains are allowed to own private classes, but the target label set cannot be seen. Therefore, it is hard to distinguish common and private classes in the training stage, and this makes the universal domain adaptation problems very challenging. For the existing method, they mostly did not recognize different categories among target private samples, and this will deteriorate representation and performance. Also, it leads to a not well generalized model to target domain. In the real-world scenarios, there will be diverse ratio of common categories, but the existing methods usually rely on Hamilton threshold values to filter out the private samples, but this is very sensitive. So the before-mentioned two problems can be summarized as common class detection and private class discovery, and they can be essentially viewed as distribution transportation problems, which can be formulated within a framework of optimal transport. Optimal transport is a promising optimization problem to seek an efficient solution for transporting one distribution to another. Here is our unified optimal transport framework for universal domain adaptation, named Uniot. Our Uniot includes two main branches: common class detection and private class discovery. For common class detection without any predefined threshold values, we consider a partial mapping problem between target samples and source prototypes based on unbalanced OT. Then, we calculate the confidence score of target samples and the source prototypes based on the couplings. The larger score means it is more likely to be a common samples, and then the top confidence samples are detected by statistics mean and assigned with pseudo-label for partial alignment. To use statistics mean as a threshold in some extremely unbalanced cases, we developed adaptive filling for handling the diverse ratios of common categories. After negative or positive filling, the ratio will achieve balance. Based on OT, we consider a full mapping problem between target samples and learnable target prototypes for representation learning and private class discovery. The laws global and local encourage the global discrimination of clusters and local consistency of samples, respectively. For evaluation metric, besides the commonly used H-score, we further introduce H-cube score for target private class discovery purpose. For those methods without private class discovery, they may have a high H-score but fail to evaluate private representation. Therefore, we add an NMI term for target private clusters in H-cube score. Compared to other SOTA methods, our Uniot achieves the best performance. With respect to H-cube score, our Uniot surpasses other methods by an extremely large margin. We also conduct application study to evaluate each designed component, and this table fully verifies the effectiveness of our design. Compared to other SOTA methods under different categories split, our Uniot is more robust to the variation of source private or target private classes. We use t-SNE to visualize the learned target features. Especially compared to dense, our Uniot learns the best target representation. To conclude, we propose a unified optimal transport for universal domain adaptation, and this is robust for realistic scenario. Also, it can learn better target representation. Our code is available here. Welcome to check it out. That's all. Thank you.